That sound, the one that still makes people near Dover feel what their grandparents felt. That 12-cylinder scream tearing through the chalk-white sky at 3,000 revolutions per minute. That sound almost never existed. Because the man who could have mass-produced the engine behind it, the man who owned the largest industrial operation on Earth, personally killed the deal. His name was Henry Ford, and his reasons for walking away from the Rolls-Royce Merlin tell you more about who actually built the weapon that dominated the air war than any documentary you have ever seen. Here is the number that rewrites the story. Packard Motor Car Company, operating out of a single plant on East Grand Boulevard in Detroit, Michigan, produced 55,523 Merlin engines. Rolls-Royce, the company whose name is literally stamped on the thing, produced 23,675. That is not a rounding error. Packard built 70% of the confirmed 79,198 Merlins. 70%. The so-called British engine that powered the Spitfire, the Hurricane, the Lancaster, the Mosquito, and eventually the aircraft that broke the Luftwaffe's back over Berlin, the P-51 Mustang, was an American-made machine in 7 out of every 10 copies. And the reason Packard got the contract at all is that Henry Ford threw it away. Late May 1940. France is falling. The British Purchasing Commission and Rolls-Royce are scrambling across the Atlantic looking for any manufacturer with the capacity to build Merlins at scale. They approach Ford. Edsel Ford, Henry's son and the company's president, negotiates directly with Secretary of the Treasury Henry Morgenthau. The deal is 9,000 engines, 6,000 for Britain, 3,000 for America. Rolls-Royce ships blueprints and a sample engine to Dearborn. Ford's engineers produce prototype crankshafts within 2 weeks. The program is moving. And then, in the first days of July 1940, Henry Ford personally pulls the plug. His stated reason is neutrality. He will build engines for America's own defense, not for foreign belligerents. This is consistent with 2 decades of public pacifism. Ford funded the Peace Ship in 1915, a doomed attempt to end the First World War by negotiation. He was associated with the America First Committee. He had built a public identity around the idea that American industry should not fuel European wars. That is the stated motive. Now here is the context that makes the stated motive very difficult to accept at face value. On July 30th, 1938, 2 years before the Merlin refusal, Henry Ford celebrated his 75th birthday at a ceremony in Dearborn, Michigan. German consular officials Karl Kapp and Fritz Heller presented him with the Grand Cross of the Supreme Order of the German Eagle, the highest honor Nazi Germany gave to foreigners. Ford was the first American to receive it. He never returned it. When pressed, he said his acceptance did not imply sympathy with Nazism. Unlike IBM's Thomas Watson, who gave his medal back in 1940, Ford kept his until the day he died. That medal did not appear out of nowhere. Ford's newspaper, the Dearborn Independent, which he purchased in 1918 and which reached a peak circulation of 900,000, published anti-Semitic articles for 91 consecutive weekly issues starting May 22, 1920. Those articles were compiled into 4 volumes titled The International Jew, translated into 16 languages, and went through 21 printings in Germany alone by 1922. Adolf Hitler kept a life-size portrait of Henry Ford behind his desk in Munich. Ford is the only American mentioned favorably in Mein Kampf. At the Nuremberg trials, Baldur von Schirach, the head of the Hitler Youth, testified that reading Ford's publications turned him anti-Semitic. Ford issued a public apology in 1927, widely regarded by historians as insincere, and shut the paper down that December. So did Ford refuse to build the Merlin because of his Nazi sympathies? Here is what the evidence actually says. A letter exists in the National Archives from Heinrich Albert, a lawyer for Ford's German subsidiary Ford-Werke, and a figure linked to German intelligence during the First World War, written to Ford executive Charles Sorensen in July 1940. It states that Ford's public refusal of British war orders had greatly helped them. That letter proves the Nazis appreciated Ford's decision. It does not prove Ford made the decision to please them. No primary document has been found in which Ford explicitly connects the Merlin refusal to any pro-German motive. Most historians who have studied this, including Neil Baldwin, Stephen Watts and Max Wallace, characterize Ford as a pacifist isolationist whose views happen to align with Nazi interests. The direct causal link is circumstantial, not documented. You can weigh context against stated motive for yourself. And then comes the part that makes the whole story buckle under its own contradictions. While Henry Ford refused to build Merlins in America, his own subsidiary, Ford of Britain, operating out of a factory in Trafford Park, Manchester, built approximately 30,428 of them. The British government funded a brand new 118-acre shadow factory adjacent to the original Ford plant, staffed it with over 17,000 workers, including more than 7,000 women, placed it under the technical authority of Rolls-Royce and the administrative control of the Ministry of Aircraft Production. And by 1944, that factory was producing 400 Merlin engines every single week. Now, people will tell you that Ford Trafford Park was British-run and Henry Ford had no say in it. That is partly true and partly misleading. Ford of Britain was chaired by Sir Percival Perry, a British patriot who had served as a government controller in the First World War. The company operated with significant de facto independence from Dearborn. Ford held 60% of shares, but did not purchase full controlling interest in its European operations until 1950. No documented evidence exists of Henry Ford attempting to prevent Ford UK from producing Merlins. But that 60% ownership stake means the man who refused to build Merlins for Britain was the majority shareholder of the company that built 30,000 of them for Britain. The corporate structure made it possible. Whether Ford chose not to intervene or simply could not intervene is a question the surviving documents do not answer. The engine contract Ford abandoned landed at Packard in September 1940, and what Packard did with it is one of the great industrial sprints of the 20th century. They signed a $130 million contract and began converting 10,400 Rolls-Royce engineering drawings from British conventions to American drafting standards. British Whitworth thread specifications had to be replicated in-house. Patent complications with the French-designed Farman supercharger gear system forced Packard to design their own epicyclic supercharger drive from scratch. They substituted American Bendix injection carburetors for the original SU float carburetors. They introduced silver-lead bearings with indium plating sourced from GM's Pontiac division, a metallurgical improvement so effective that Rolls-Royce adopted it for their own production. And on August 2, 1941, 11 months after signing the contract, the first two Packard-built Merlins ran on test stands in Detroit. 11 months from contract to running engine. There is a claim you will hear constantly in discussions about Packard Merlins, which is that Packard's mass production techniques built the tolerances much closer and more consistent than Rolls-Royce's hand-built approach. It is a satisfying story. It flatters American industrial mythology, and no documented tolerance data exists to confirm it. The famous quote about tolerances being too wide actually comes from Stanley Hooker's autobiography, and it refers to Ford UK, not Packard. The Rolls-Royce Heritage Trust has stated that Rolls-Royce tolerances and specifications were followed to the letter by Packard. Aviation historian Callum Douglas has documented that both Rolls-Royce and Packard relied almost entirely on the same American-made automatic machine tools, Cincinnati and Hardinge machines, with approximately 70% of parts guaranteed interchangeable between manufacturers. Rolls-Royce's own Glasgow Shadow factory employed 40% female semi-skilled labour, workers who had never assembled an engine of any kind before. The idea that Rolls-Royce was a workshop of master craftsmen hand-fitting every bearing, while Packard was a precision automated operation, is mythology. They were both industrial mass production operations using the same machines. The real difference was speed. Packard got to scale faster. There is a man whose name should be as famous as R.J. Mitchell or Sidney Cam, and almost nobody outside of specialist aviation circles has heard of him. His name is Stanley George Hooker. Born September 30th, 1907 in Sheerness, Kent, the youngest child of a working-class family. He won a scholarship to Imperial College London and graduated with a first-class degree in mathematics in 1931, specialising in hydrodynamics. He earned a doctorate in aerodynamics at Brasenose College, Oxford. Before Rolls-Royce, he worked on torpedo propulsion at the Admiralty and anti-aircraft rockets at Woolwich Arsenal. In late 1937, he applied to Rolls-Royce for an engineering position. During his interview, the managing director, Ernest Hives, reviewed his academic credentials and said, "You are not much of an engineer, are you?" That line became the title of Hooker's autobiography. He joined in January 1938. The reason you need to know Stanley Hooker's name is that the Merlin engine that entered production in 1937 produced 1,030 horsepower. The Merlin engine that existed when the war ended produced 2,070 horsepower. That is a doubling of output from the same 27-litre displacement, the same bore, the same stroke, the same fundamental architecture. And the single largest contributor to that doubling was Hooker's supercharger work. When Hooker arrived at Rolls-Royce, the supercharger department had not fundamentally revised the Merlin supercharger design since 1934. They were engineering empirically, adjusting by trial and error. Hooker applied dimensional analysis and theoretical aerodynamics, the mathematical methods he had learned at Imperial and Oxford, to the problem. He identified that the original intake duct was inefficient and badly shaped. He redesigned the air intake, improved the impeller guide vanes and diffuser, and raised supercharger efficiency from 68% to 76%. That sounds like a small number. It pushed the maximum power altitude from 16,000 feet to over 19,000 feet. In a war fought vertically, where the pilot with more altitude owns the engagement, those 3,000 feet were the margin between killing and dying. His masterpiece was the two-stage, two-speed intercooled supercharger. When the Air Ministry asked for a high-altitude Merlin and suggested turbocharging, Hooker said no, too heavy, too complex. Instead, he designed a system using a modified Vulture supercharger as the first stage and a Merlin 46 supercharger as the second stage, connected by a liquid-cooled intercooler that prevented the compressed charge from detonating. The system achieved a compression ratio of roughly 6.5 to 1 versus 3.5 to 1 for the original Merlin 3. The first production Merlin 61 was completed on March 2, 1942. At 30,000 feet, a Spitfire 9 with a Merlin 61 was 70 miles per hour faster than a Spitfire 5 with a Merlin 45. 70 miles per hour from the same airframe with a different supercharger. The power progression tells the story of what Hooker enabled. The Merlin 2 in 1937, 1,030 horsepower. The Merlin 20 in 1940, 1,480 horsepower with a single-stage, two-speed supercharger. The Merlin 45 in 1941, 1,515 horsepower. The Merlin 61 in 1942, 1,565 horsepower at 12,000 feet, but still producing 1,390 horsepower at 23,500 feet, which is where the air war was actually fought. The Merlin 66 in 1943, 1,720 horsepower, and the Merlin 130 in 1944, 2,070 horsepower. One engine block, one bore and stroke, 8 years, a full doubling. Try to find a biography of Stanley Hooker. Go ahead. Standard references yield almost nothing. The man who arguably contributed more to Allied air superiority than any other single engineer has a Wikipedia page shorter than most minor pop stars. His autobiography, Not Much of an Engineer, published by Airlife in 1984 and co-written with Bill Gunston, is the single substantial source on his life. It covers the Merlin superchargers, his jet engine work with Frank Whittle, his leadership of Bristol Siddeley, where he directed the Olympus engine for Concorde and the Pegasus for the Harrier, and his return from retirement to rescue the Rolls-Royce RB211 program after it bankrupted the company. He was elected Fellow of the Royal Society in 1962 and knighted in 1974. He died on May 24, 1984, the day before the book was published. The absence of biographical material on Hooker is itself the proof of how history treats the people who improve existing systems rather than invent new ones. Mitchell designed the Spitfire, so Mitchell gets the statue. Hooker doubled the power of the engine inside it, and most people have never heard his name. There was a flaw in the Merlin that German pilots exploited from the very first days of combat, and fixing it required 2 women, 1 engineer, and 1 American corporation. The early Merlin used an SU float carburetor, the same basic technology as a road car. When a pilot pushed the stick forward into a dive under negative G forces, the fuel in the float chamber was thrown to the top, starving the jets and causing the engine to cut out. If negative G continued, the float dropped to the floor, the needle valve opened fully, and the engine flooded with fuel and died completely. The Daimler Benz DB601 in the BF109 used Bosch direct fuel injection. Negative G had 0 effect. German pilots learned to escape pursuing Spitfires and Hurricanes by simply pushing forward into a dive at full power. RAF pilots had to half-roll inverted before diving to maintain positive G throughout, a maneuver that cost them between 1 and 4 seconds. In a dogfight, 4 seconds is a lifetime. The first fix came from Beatrice Tilly Schilling, one of the first women to earn an engineering degree at her university, a Brooklands Gold Star holder for lapping the circuit at 106 miles per hour on a Norton motorcycle, and by 1939 the technical officer in charge of carburetor research and development at the Royal Aircraft Establishment at Farnborough. In late 1940, Schilling devised the RAE restrictor, a simple brass washer with a precisely calibrated central orifice that limited maximum fuel flow to match the engine's demand at full power. It could not eliminate the initial lean cut during the first moments of negative G, but it prevented the catastrophic flooding that killed the engine entirely. The critical advantage was that it could be installed without removing the carburetor or taking the aircraft out of service. By March 1941, Schilling and her team had fitted the device across RAF Fighter Command. Stanley Hooker himself reportedly coined the nickname that stuck to it ever after. The permanent solution was the Bendix-Stromberg pressure carburetor, designed by the American Bendix Aviation Corporation's Stromberg division. It eliminated the float entirely. Fuel was kept under constant pressure and sprayed at 5 psi directly into the supercharger inlet through a servo-operated metering valve. Negative G had zero effect. Packard used Bendix injection carburetors on the V1650 from the very start of production. British-built Merlins adopted the Bendix-Stromberg beginning in 1943 on the Merlin 66, which meant that the Spitfire 9 that entered service with the Biggin Hill wing in March 1943 was the first Spitfire variant to be completely immune to the negative G problem that had plagued the aircraft since 1940. An American carburetor, designed in Connecticut, solved a British engine flaw that a British woman had patched with a brass washer. And then there is the fuel. The Merlin 3 on 87-octane fuel produced 1,030 horsepower at a maximum boost of 6¼ psi. The same Merlin 3 on 100-octane fuel produced 1,310 horsepower at 12 psi emergency boost. That is a 27% power increase from changing nothing but the liquid you pour into the tank. It translated to an extra 25 miles per hour at sea level and 34 miles per hour at 10,000 feet. By 1941, the Merlin 45 was cleared to 16 pounds per square inch boost on 100-octane fuel. By late 1943, with the introduction of 150-octane fuel, the Merlin 66 reached 25 psi and 2,000 horsepower at sea level. The RAF did not stumble into this advantage. Air Commodore Rod Banks recommended 100-octane as the standard fuel grade in January 1937, 3 years before the Battle of Britain. The Air Ministry placed bulk supply contracts that year. The first tanker of BAM 100 fuel arrived from the Esso refinery in Aruba in June 1939. By March 1940, every Spitfire and Hurricane was being converted. By July 10, 1940, the day the Battle of Britain officially began, Fighter Command was effectively fully converted to 100-octane fuel. Germany could not match this. During the Battle of Britain, the vast majority of Bf 109Es ran on B4 fuel at 87 octane, predominantly synthetic fuel from hydrogenated coal. A small number of DB601N equipped fighters used C3 fuel at approximately 95 to 96 octane. But C3 supply was severely limited, accounting for roughly 20% of German aviation fuel production by 1941. Germany had almost no domestic petroleum. It depended on synthetic production and Romanian oil from Ploesti. It never produced 100-octane equivalent in meaningful quantity. When Allied strategic bombing hit the synthetic fuel plants in 1944, German fuel production collapsed precisely as their newest engines demanded higher-grade fuel to function. The chemistry of petroleum processing was as decisive as the engineering of the engines that burned it. Speaking of the competition, every documentary about the Merlin eventually compares it to the Daimler Benz DB601, and almost every one of them gets the displacement wrong. The DB601 displaced approximately 33.9 litres, not 39 litres. The bore was 150 millimetres, the stroke 160, 33.9 litres. The 39-litre figure that circulates in popular accounts does not correspond to any actual engine in the DB600 series, and likely results from confusion with the DB603 at 44.5 litres. Getting this right matters because the Merlin, at 27 litres, was producing comparable or superior power from a significantly smaller displacement, which tells you everything about what supercharger efficiency and fuel quality actually deliver. The DB601A produced 1085 horsepower on 87-octane fuel with direct fuel injection and a hydraulic variable speed supercharger. The Merlin 3 on 100 octane produced 1310 horsepower with a float carburetor and a single-speed supercharger. By 1942, the comparison was not even close. The Daimler Benz line eventually reached 2,000 PS with the DB605DC using water methanol injection. But that system consumed scarce chemicals, was unreliable in the field, and arrived too late in too few numbers. The Merlin's growth came from fundamental aerodynamic improvement of the supercharger and progressively better fuel. Structural advantages: repeatable, sustainable. The German approach was increasingly desperate. The British approach was methodical. And that is the strategic lesson buried inside the engineering. One engine block, 50-plus variants, 1,030 horsepower to 2,070 horsepower across 8 years without changing the bore or the stroke. The Merlin 2 powered the Spitfire 1 and Hurricane 1 in 1940. The Merlin 20 transformed the Hurricane into a ground attack platform. The Merlin 21 and 25 powered the Mosquito, the unarmed fast bomber that could outrun most contemporary fighters at 428 miles per hour. The aircraft the audience for this kind of content has been asking to hear about for years. 4 Merlin XX hauled the Lancaster across Germany at night. The Packard V16503, a 2-stage Merlin with American carburetors, turned the P-51 Mustang from a capable low-altitude fighter into the war's premier long-range escort, 100 miles per hour faster at altitude than the Allison-powered original. The Merlin 113 and 114 pushed the Mosquito PR-34 to 42,000 feet for photographic reconnaissance over territory no other aircraft could reach. The British did not do this by inventing a wonder weapon. They did it by refusing to stop improving the weapon they already had. Every variant addressed a specific tactical requirement. Every power increase came from a specific engineering change. A better supercharger, a better carburetor, better fuel, better metallurgy. And they did it across 5 factories in 3 countries, with British engineers writing the specifications, American factories building the majority of units, and American chemists refining the fuel that unlocked the power. This was never a British engine. It was never an American engine. It was a transatlantic industrial weapon, assembled from British thermodynamic theory, American mass production capacity, American petroleum chemistry, a mathematician from Sheerness who was told he was not much of an engineer, a woman from Waterlooville who rode Nortons faster than most men, and a car company in Detroit that spent 11 months converting 10,000 drawings from imperial to American standards, because Henry Ford would not do the job himself. 79,198 confirmed Merlins, not the 150,000 figure you will see repeated without a source. 79,198, built by Rolls-Royce at Derby, Crewe and Glasgow, by Ford at Trafford Park in Manchester, and by Packard at East Grand Boulevard in Detroit. 3 nations' worth of labour poured into 27 litres of displacement that doubled its output in 8 years, and powered the fighters that made daylight bombing survivable, the bombers that made nighttime strategic offensive possible, and the reconnaissance aircraft that flew above everything else in the sky. The Merlin did not win the war. Nothing won the war by itself. But the air war over Europe between 1940 and 1945 was not survivable without it. And the messy, multinational, politically compromised, corporately fragmented story of how it got built is worth more than any myth about a single company in Derby handcrafting victory out of British genius alone. The genius was real. It was also shared. And the man who could have built more of it than anyone else on earth said no, cited neutrality, kept his Nazi medal, and watched his own British subsidiary build 30,000 of them anyway. That is the sound you hear over Dover. That is what it took to make it.